So it says up here that what we're doing is we're working the activity finding and interpreting key features of quadratics, which is number 15 over there on the board. So I wanted to work an example. This example is similar to the potato gun problem that we did in class last week. So let's read the question. A hovercraft takes off from a platform. Its height in meters y is dependent on the time seconds after takeoff and can be modeled with the function y equals negative x minus 11 times x plus 3. Okay, so you've got a hovercraft. So all of you draw a coordinate plane on your paper. We've got a hovercraft, and the hovercraft starts on the y-axis. And it flies up, and it peaks out, and it flies back down to the ground. Okay? And they want us to tell some stuff about that. Now, the y-intercept in a function is always your starting point. Say starting point. So in math, the y-intercept is always the starting point. Okay? Now, where it touches the ground is also the x what? Intercept. Okay? Or we could call it the solution. Or we could call it a zero of the function. Right? And then the maximum or minimums always occur at the what? Vertex. The maximums and minimums always occur at the vertex. So this is a quadratic problem, and they want us to calculate the y-intercept, the vertex, and the solutions. That's all they're wanting us to do. Okay? Now let's go back to the function. The function is written in x-intercept form. Okay, now there are three forms of quadratic equations. Okay, the first one we learned was standard form. And it is ax squared plus bx plus c equals 0. That's standard form. Okay, and then you have vertex form. And it is f of x equals a times x minus h all squared plus k. That's vertex form. And the final form is x-intercept form. And it's f of x equals a times x minus x minus s times x minus t. So those are the three forms of quadratic equations: standard, vertex, and x-intercept. Now, vertex form is called vertex form because calculating the vertex is very easy when it's in vertex form. And x-intercept form is called x-intercept form because finding the x-intercepts is very easy. X-intercept form is nothing more than standard form factored. You know, when we factor a standard form equation, it factors into two binomials if it factors. And so let's look at our problem. They want us to tell how many seconds after takeoff will it land on the ground. They want me to tell what the max is. They wanted me to tell how many seconds went by and the max occurred. So after how many seconds did the maximum occur? And then they want me to tell me what was the height of the hovercraft when it took off, the starting point. The height of the hovercraft when it took off is the what?
Starting point.
So in this right here, they just want to know what's the y-intercept. Okay? So let's take our function. Let's write it right here. Y equals negative parentheses x minus 11 times x plus 3. And let's set that function equal to 0. When we set it equal to 0, negative x minus 11 times x plus 3, when we set this function equal to 0 and solve, our solutions will be where the hovercraft touched the ground. They'll be the x-intercepts. So to solve that, I'm going to take the x minus 11 and I'm going to set it equal to 0. X minus 11 equals 0. And I'm going to take the x plus 3 and set it equal to 0 as well. And so when we solve each of these, I'll add 11 on both sides here, and I get x equals 11. And I will subtract 3 on both sides here, and so I get x equals negative 3. So those are my two x-intercepts. Say x-intercepts. So let's go over to the graph and label them. So here's my graph, right? And so I know that it crosses the x-axis right here at negative 3 and right here at 11. Now the first question says, after how many seconds did the hovergraph hit the ground? Well, did the hovergraph hit the ground at negative 3 seconds? There's no such thing as negative 3 seconds. If I'm in a pool and I say to you, I'm about to go under the water, time me. And I went under, you would say when I came back up, you were in there negative 22 seconds. Right? There's no such thing. Right? Time you're always accumulating in a forward fashion. So the hovercraft went up. And see, like right here, it's 1 second into flight right here. Then 2 seconds, 3 seconds, 4, 5, 6, 7, 8, 9, 10, and boom, it hits the ground at 11, right? So how many seconds went by before it hit the ground? 11 seconds. So that's that blank. How many seconds after takeoff will the hovercraft land on the ground? 11 seconds. Okay? Now look at the next two questions. What is the maximum height? How many seconds will go until we get the maximum height? So in both of these, they're talking about maximum what? The maximum always occurs at the vertex. Okay, so if the maximum always occurs at the vertex and they're asking me what is the maximum, then I probably should go find the vertex. Okay, so what we're going to do is we're going to roll over here to our equation, and I'm going to rewrite it. Y equals negative x minus 11 times x plus 3. And I want to find the vertex. So if I want to find the vertex of this equation right here, I don't know how to find the vertex when it's in x-intercept form. I can find the vertex when it's in standard form, right? So if it were in standard form, I could find the vertex. If it were in vertex form, I could find the vertex. But when it's in x-intercept form, there's not like a formula for the vertex. Are you hearing me? So the best thing to do would be to take this x-intercept form and convert it into standard form. What should I do first to get my equation right here to look like the standard form right there? And so in order for me to convert this into standard form, I need to FOIL it. FOIL means multiply this x times both and multiply this negative 11 times both. When you multiply two binomials, we call it FOIL. But really all we're doing is distributing the x and the negative 11. Okay, so all of you go ahead and FOIL it. Okay, so let's FOIL it together. So I've got x times x, and what does that give me? So I've got y equals negative, and then I'm going to put a parentheses, right? X times x is x squared. And then x times 3 is 3x. And negative 11 times x is negative 11x. And negative 11 times 3 is negative 33. And now inside that parentheses, I'm going to combine like terms. So I've got y equals negative parentheses x squared, and you can see 3x and negative 11x are like terms. Say like terms. Like terms. So I got minus 8x minus 33. Now at this point, what do I do to finish up converting this into standard form? Distribute the negative. I'm going to distribute the negative, and so I have y equals negative x squared plus 8x plus 33. And now I've got it in standard form, and I'm going to circle my standard form equation. Now, what was the point of us putting it in standard form? The point was we wanted to know what the vertex was, right? So the vertex, when something is in standard form, can be used using the formula what? Negative b over 2a. Good. But then we need a y, don't we? Okay, so let's all calculate negative b over 2a. So negative b is going to be x equals negative 8 over 2 times a, which is negative 1. And so I've got negative 8 over negative 2, which equals what? 4. Now, 4 is your x value in your vertex, but I don't know what my y is, do I? So to calculate my y, go ahead, Maria. Yeah, plug 4 in for the x right there and for this x right here. And so I have y equals negative. And when I put a number in for a letter, I have to put that number in parentheses. 4 squared plus 8 times 4 plus 33. And now at this point, the most common thing students do wrong is they do the negative times the 4 first. You cannot do the negative times the 4 first. You have to do the 4 squared first. What's 4 squared? So I have y equals negative, and then in parentheses 16 plus 32 plus 33. So what I'm doing is I'm adding negative 16 plus 32 plus 33, and what do you get? 49. Now, let's look at our vertex. Here's my vertex. My vertex is the point 4, 49. So what does the 4 mean in the vertex? What does the 4 mean in the vertex? The 4 right here, what it means is 4 seconds into flight, it reaches its maximum height. And what is its maximum height? 49 meters high. So 4 seconds into flight, it reaches its maximum. And what is its maximum? 49 feet high. So let's go back to our graph. Okay, and what we're saying is 1, 2, 3, 4 seconds into flight, it reaches its maximum right here. And what is its maximum? 49 what? Meters high, right? So the 4 in the vertex is how much time went by till it reached its max. And the 49 is what the max actually is. It's how high? 49 feet high. So let's go back to the question and look what it says right here. What is the maximum height the hovercraft will reach? What is the answer there? 49 meters. And then right here it says how many seconds after taking off will the hovercraft reach its max? 4 seconds after taking off, it'll reach its max. Now the last question says, what is the height of the hovercraft at the time of takeoff? So what's the starting point? Now in math, the starting point is the y-intercept. So let's go back to our function in standard form. Here's our function in standard form. What is the y-intercept just by looking at the function? 33. See, if you want the y-intercept, you put a 0 in for what? X. If I put a 0 in for x right here, I get 0, right? And if I put a 0 in for x right there, I get 0, right? So what's 0 plus 0 plus 33? 33. So the y-intercept is 33. Okay, so when we look at our graph, the y-intercept is 33. So how high off the ground was the hovercraft when it started flight? The answer is right there on the board. 33 what? 33 what? Meters. Okay. The initial height of the hovercraft is the y-intercept, right? Because I told you the y-intercept is the starting point.